All right, so we're going to get started. First of all, thank you so much and welcome to Dataiku and phData's AWS Dev Day, a motion classification in videos. Before we get started, I just want to touch on a couple housekeeping items. So this presentation is being recorded and will be shared with you following the event. If you have any questions throughout the presentation, please feel free to submit them in the Q&A box, and we will either answer them verbally or in the chat. Following the project walkthrough, we will hold 30 minutes of office hours where you will be able to begin the project on your own. You should have received your login credentials this morning, as well as a workbook with step-by-step instructions, but our presenters will be here for all of office hours to answer any questions that you might have. So for today's agenda, we're going to start off with leveraging Dataiku and AWS for data science. This will be presented by John Posada, Dataiku Partner Solutions Architect. And then we'll jump into our hands-on workshop led by Robert Koop, the General Manager of Machine Learning at phData. The use case we're working on today is a motion classification on video. And then after we're done with that, we will hop into our office hours. And again, please do not log into your credentials until we reach the office hours portion and you are prompted to do so. So without further ado, I would like to hand this over to John, and he will go over your path to enterprise AI.
Hi, everybody. My name is John Posada, and today I'll be talking to you about your path to enterprise AI using Dataiku. Can everyone see my screen so far? Excellent. Okay, so today I want to talk to you about what's really under the hood when it comes to Dataiku's platform specifically. So the first thing I want to talk about is what we call storage. So with Dataiku, we leverage different local resources, and we work with different cloud providers, but preference obviously is with AWS for today, and obviously in general. So with that being said, we also work with different data sources, like for example, Excel, Snowflake, MongoDB, Teradata, Cassandra, as you see here as one of our parts of our resources. The second one is the platform has a lot of user relevancy. So what that means is we have different ways of unifying across through different browsers and IDEs within inside the platform. So that means is you can look at exploration and pipelining of data. You can look at building visualizations and statistics, completing coding environments, collaboration and project management, machine learning and auto ML, as well as like audit logging, monitoring and scheduling of your predictive models and the consumption of those models, as well as working with different browsers and IDEs as you see here. When it comes to production deployment, we also work with orchestration of data flows. We work with deployment of full flows. We work with the deployment of model APIs, as well as data monitoring, model drift, data drift, as well as systems monitoring as well. And then when it comes to computation, we are very friendly when it comes to computation. So we work with on-prem, on the cloud, and we work with different types of resources and services that are able to be enabled with inside of the platform. So for example, you can take advantage of running Spark on Kubernetes or using EMR or EKS specifically if necessary for all your computational needs with respect to your data computation. And then lastly, we're very extensible with respect to the different outputs for your resources. So for example, if you want the data sets to be provided as part of specific dashboards, maybe Tableau or other dashboards, as well as like different resources for APIs, we are able to work in that capacity as well. So the platform is much more than just software alone. So from usage to value, we do provide you with an academy, which is located at academy.dataiku.com, where we have like on-demand training and certification for you and your team members as well, and even your organization. We also have a community where you're able to get peer-to-peer support and best practices when it comes to the actual platform and the usage of the platform, as well as an online repository of free plugins that you can use to actually extend what you're going to be seeing today, which is what we call a flow inside of our project. We also have supporting company success. So we have a great customer success team that would help you with the orchestration of your success with respect to enterprise AI. We also have implementation services that would help you with the architecture, the deployment, the setup, and the training of the platform in your organization, as well as we have a great customer support with different types of SLAs available easily for you with respect to the platform when it comes to using it. Then we also like to focus on transforming your organization. So we do have different data science services that are available, hands-on for assistance for your projects that we do offer. We also offer strategic advisory with respect to the AI maturity, assessments and acceleration of your organizational transformation, through best practices and some data recommendations. And lastly, we do have business value consulting, which will help you with measuring and driving the value of your AI initiatives as well. Now, the platform itself is a solution overview where we're looking at really an end-to-end solution. So this means from looking at data, access to really operationalized models. So as you see here, we have it partitioned into three really main points. The first one is data management, which we have visual auto prep and code environments. The second is where we're really going to look at machine learning, where we're going to look at either visual auto ML or actual ML written in code, or look at like the visual pipelines of all the different individual steps that were built to build specific pipeline, which we also call flow. And then model development or deployment in this case, where we're actually going to look at, how can we deploy that model that was built into a production environment, consume that model, and also monitor that model if necessary. But what does this really all mean? Well, we do have different personas or profiles, as you can call them, that are attached to each of these sub-processes. So the first one would be, for example, business analysts. They'd be responsible for finding, understanding, and preparing data, as well as business modeling prototype on the machine learning point, or even when it comes to just monitoring the results. But then in addition to the business analysts, you also have like the data scientists who will be responsible for really helping for also building plugins specifically for the business analysts to use with respect to the platform, as well as building business monitoring dashboards for the actual business analysts to consume as well, if necessary, throughout this entire end-to-end process. But that also means that the data science is also available for, productivity and the extension of, say, for instance, your EDA processes when it comes to visual auto prep, as well as using a baseline use for considering how to optimize models. For example, if you're using the auto ML feature that we offer, then how can you go ahead and optimize some of these models by changing some of their parameters or hyperparameters if necessary. And then also consider, for example, a data engineer who's going to be responsible for how to optimize the speed, for example, of your pipelines or flows that have been built to make sure we can optimize the speed and the computation, and then make sure that we can integrate these pipelines when it comes to actually your model deployment stage. And then lastly, we have what you call the analytics leader. And they're the ones that really have to understand the progress between flows and projects and how everything's looking, and then also be able to monitor those results and report those results specifically, for instance, to like C-suite executives or whoever they report to specifically when it comes to trying to understand what's going on with the business, especially when it comes to accessing the data to operationalizing the data into specific models for consumption. So what does this also mean with respect to the platform itself? So the platform is agnostic. So we support all data project stakeholders. We work with all different types of profiles. As you see here, it is an end-to-end platform solution. So we do consider the four major points, which is how to grab the data, catalog it, connect to it, how to go ahead and provide EDA preparation so you can look at how to prepare your data in the way that you need to, how to consider building your data into your predictive models, whether you're going to use the auto ML recipes we offer, or if you want to bring in your own code environments, and how we're going to grab those models and then go ahead and deploy them to a production environment. With that being said, we call each of these individual nodes recipes. And so this entire process, which is what you would consider a pipeline, is also what we call a flow. And each of these individual nodes are what we call recipes, which means, just from the perspective, think of what a recipe is. If you were a chef or trying to make a meal, there are different pieces of steps that need to be followed in each of these individual recipes. And this will basically help you build that end-to-end process that you need specifically. And with all that being said, we do look at recipes from different types of perspectives as well. If they're yellow, we look at them as being visual. So basically they have like the drag and drop feature. If they're orange, you can basically go ahead and code what you would like to do with respect to your recipes. If they're blue, they're just data sources. And if they're green, they just represent our auto ML recipes. And this is basically all considering as well the governance, and then as well as the audit and reuse and the versioning of your flows specifically as well. So basically you'll find out who's done what, who's corrected what, who's changed anything, who's deleted something. And you can make these processes repeatable as well, or create chains of these pipelines if necessary for example, in future projects that are going to be constructed. So with that being said, I'm going to send it over to phData, and we're going to have Coop present to you. If you have any questions, please let me know, or we can follow up at the end when we have Q&A.
So hi, I'm Robert Coop. I just go by Coop. I'm the general manager of machine learning here at phData. phData is a full service data engineering, machine learning engineering, and data science firm. I have just 3 slides or so of overview about phData, and then we'll jump in and get started. We, as I said, it's full service, so we really are involved in every step of the projects that we help with, from building out the platforms to building machine learning models, deploying and managing those models, and then on the data engineering side, building out data pipelines and transformations and managing and monitoring those systems. The services we offer are across the whole spectrum. Anything from the strategic side, where we have project and data strategy, data engineering, where we have pipelines, POCs, migrations, machine learning, where we have data science, ML engineering, ML ops framework deployment, and then managed services to help operate all of it. On the data science end, which is more relevant to what we're doing today, we tend to be involved in the process as early as allowed to be in the use case exploration, all the way through validation and testing. And honestly, this slide needs to be updated because there's a bubble just past that of the deployment and monitoring. So now that we've covered that, let's jump into the actual project. So this is a motion detection in videos using deep learning within Dataiku. So kind of the agenda we'll go through is the project overview, setting up, preparing videos, doing the deep learning, testing and validating, deploying and distributing the work. So this should take you from 0 to a API and redistributable application. A little bit of a preamble here, as Sydney mentioned at the very beginning. The format of this workshop is that I will go through the project step by step and walk through and demonstrate how it would be done. We will have office hours at the end of the workshop so that you can get started on creating your own version of the project and all that. So it is not recommended to try and operate or run the project, while we're doing this. Due to the amount of data involved, some of these steps take upwards of 20 to 30 minutes. And certainly if you get into the actual deep learning training, I think I trained this thing for 48 hours. So it can take quite some time. So let's talk about the project. First of all, this is an interesting academic exercise, at least I think. But there's a question of, why we'd want to do this at all. So the goal here is, given a video of someone, tell what emotion they're expressing. There are real world uses for this, some of which are being developed right now, and I've seen POCs in corporate settings, others which are more kind of theoretical. So in the retail space, there's some interest in measuring the change of emotion due to experience. So imagine a store with a security camera on the door as you enter and exit. You look at the emotion content of someone's face when they come in, you look when they go out, and you try and determine, did this person become angry? Did they become happy? Are they expressing neutral emotions both times? In the security world, it's just a matter of monitoring the emotion that you're able to see on the people within a given camera. So the question would be, is there someone who looks unusually angry or sad or other extreme emotions not being expressed by people that are otherwise in the frame? And in the commercial world, it gets into the more theoretical, and this example probably is in the more controversial. We could look at the cameras of the participants of a Zoom meeting and determine if they are engaged, frustrated, neutral, happy, so on and so forth. So there's a lot that can be done with this system. So let's talk about the system in particular. The workflow that we will go through, first we have to obtain some training data, and then we will extract images from those videos. So it is possible to do deep learning and to do all of this processing directly on video files. However, it's much harder than using images. So we extract what we hope are representative images from these videos. We classify the emotion content within each image, recombine those to determine the content of the video itself, and then deploy the whole thing as an application and an API. And as we go through this, please, if you have any questions, submit them to that question and answer section. If I do happen to glance over and see some that I can address, I will. If not, we can always more interactively work during the workshop section, or during the office hour section after the workshop. So here's how we will do the classification itself. We pretty much will take a majority vote of the frames classifications. So we've arbitrarily decided to pull 21 frames out of each video, classify each frame. We'll take the label that appears most often, and we will call that the label for the video and see how that works. The data set we're using is the Ryerson Audio-Visual Database of Emotional Speech and Song, which is actually a relatively interesting video data set. There's 24 different actors, half male, half female. There's 2 different statements that they speak in a neutral accent, and they will speak this statement with a neutral affect, and then also speak it while acting out different emotions. There's a normal and strong version of each emotion. So one where they're, realistically displaying anger, for example, and then another one where they are over the top, overacting the anger. There's also a separate part of the data set, I think, that involves the song portion, though we're not really using that. So the actors are here. I will take a second to address a very hot issue in machine learning right now, and one that is very apparent here. This is not a very diverse group of actors, so we would expect that our model will come out and be biased for accuracy across this group, as opposed to a more diverse group. That's just a limitation of the data set that we're working with. So one of the questions came in that's interesting as far as, defining a facial expression as being representative of an emotion is difficult. How did we do that in this case? We have done that just by fact of these labeled videos. So I'll kind of show you how that works. So here is a neutral video, and hopefully the video itself comes in relatively nice, but you can hear the audio.
Kids are talking by the door.
So this is just a neutral statement. You can see the actual sentence they're reading is fairly nonsensical. It's not anything with a bunch of content. Here's the same actor doing a happy version.
Kids are talking by the door.
And the same actor doing a angry version.
Kids are talking by the door.
And for what it's worth here, I think those were the strong expressions of emotion, so they're definitely exaggerated. The audio is there just for example. We are extracting images from this video and discarding the audio entirely. It would be an interesting follow-on project to do some audio analytics here, but that is outside the scope. So within these videos, we will extract certain frames. And you can see here the labeling problem comes into play, because this is actually the angry video, but the first frame is a relatively neutral face. However, by extracting many frames from this video, the idea is that the frames with actual angry expressions will outnumber the mislabeled sort of neutral frames. And that's how we get around that problem of labeling the images. It's just going off the principle that we have enough data and enough images that are correctly labeled so the outliers kind of fade away. Sorry, I'm just looking at this Q&A thing. I'll probably just do the question and answer in batches. It's just kind of distracting to look over all the time. So here's just a quick section for setting up. You should have received your Dataiku URL and credentials and all that before this, as well as the workbook. The workbook is highly recommended. It will go through every single step that I'm doing here, and has all of the code included in the PDF and all that. So now let's just dive into the projects and talk about how we do each step. So we'll start with the video preparation. The video preparation is going to consist of first some environmental setup. So we have to install this deep learning for plugin, or deep learning for images plugin. Then we have to create a custom Python code environment to use the packages we need to use. We download the videos, extract the frames, and build a training and testing data set. So now I will jump over to our actual project. And someone please pipe up in the chat or Q&A as far as if you can, I assume you can see this. Tell me if you can't. So we will look at the preparing video section. So first, oh, I'm sorry. No. I'm getting ahead of myself. First, we will set up the environment. So I need to install the deep learning plugin. If I go to my menu up here, here is the kind of server level menu options, and there's one for plugins. And we'll talk a little bit later about some of the available plugins, but if we type in deep learning, they've added a few since the last time I looked, which is interesting. But we have a deep learning on images GPU, as well as a deep learning on images CPU. And that's going to depend on the type of environment in which you're running this experiment. And you can also, it may depend on the type of container to which you're deploying the execution, which we'll talk more later about that. In this case, we install the deep learning CPU plugin, which will give us a couple recipes and macros and techniques for operating with deep learning networks. We also need a code environment, so I can go to administration. And by default, Dataiku is going to give you a Python environment, an R environment, and they're set up with a lot of standard packages in terms of, pandas and SciPy and all that good stuff. If we want our own custom packages, I can go to code environments and create a new Python environment. I can select my Python version, give it a name, decide if I want to use Conda, a couple other default options, which I'd recommend just keeping the same. I've created one here called Py27 OpenCV. If I open that up, within these code environments, really the only things that you need to configure for this project is in packages to install. And here is where I can add packages to the environment and then hit update, and it will effectively do a pip install of that package into this environment. And later I can set this environment as being the environment in which certain steps of the recipe are supposed to be executed. A good question came up just in general as far as, like I mentioned before with the bias issue, asking about whether skin color is something that will lend itself to misclassification or misinterpretation. That is absolutely a very real problem with this project. It is one that I have not addressed because we are testing and training from that same data set. So they all have roughly similar skin colors and all that. So it doesn't really come up. But in a real world application, that is something that would need to be dealt with. So now we have our environment set up and we want to actually obtain some videos. So in our recipes, we can do visual recipes, which are pretty user-friendly, sort of drag and drop and UI-driven recipes. We can also do code recipes. In this case, I want to do a shell code recipe, which lets me execute arbitrary shell commands. So I've created one here that will download these videos. So what this is doing is just a bash script. It uses a for loop to loop through the index 1 through 24, and we can build up the URL for each zip file of the videos and download them one after the other. One thing that's interesting here, Dataiku will give you different shell environment variables so that you don't have to worry about the path of your folder or users or anything like that. So I just output this to my folder path as a zip file. I then unzip the zip file. I move the videos out to where I want them, and then I clean up and delete. It's worth noting that I only take some of the videos, the ones starting with O2. Those are the videos that do not have audio associated with them. If I took all of the videos, I would end up with duplicates of the videos, which would cause problems when we try and separate it out into training and testing. So if you wanted to run this, this will download 24 different zip files, one for each actor. which ends up being a lot of data. I have a modified version. Your project won't have that, but this just demonstrates what you can do to get less data. If we just change this sequence, instead of from 1 to 24, change it from 1 to 1, for example, that will only do the first actor, and you'll end up with less data. So the partial video ends up with 60 files of about 265 megs. The version that downloads all the videos gives you 1,440 files at about 6.3 gigs. So there's a lot of data here to work with. So now we have downloaded the videos and put them into a folder. The next step is going to be to extract the frames from the videos. So for that, I have another code recipe. And in this case, it is my Python code. So I can open that up. And one thing I need to do here is, this is where we will be using OpenCV to extract the video frames. So under the advanced section of this code recipe, here's where I select my environment. And I want to be sure to select the environment in which I've installed OpenCV, so that gets selected as usual. And here is a container configuration where you can tell Dataiku where to execute that. I'll talk a little bit more about that when we get to the deep learning part. And in the code, there's one thing that you may notice. I'm importing this extract frame function from custom video processing. That is something that I created. So I want to be able to reuse this extract frame. Up in the menu here for the project, there's a section for code libraries. So I can create my own functions that are then can be shared within different parts of this flow. So that's exactly what I've done here. This is the function that imports OpenCV and will extract a frame from the video. So what we do here is, this will take a path of a video folder, and then the frame percentage. So 0 would be the first frame of the video, 100 is the last frame of the video, and 50 would be the frame that occurs right in the middle. The video folder object is actually going to be a Dataiku supplied object that lets us access contents of a folder. The nice part about that is it abstracts away any concern about where this folder actually lives. So I get the path of the video within the folder, and then I can call get download stream as a function in order to get a stream that can read that path from that folder. And let me actually zoom in here a little bit, which might make this a little easier on folks. So what this does for me, this folder might be on the local file system, in which case this is just going to give me a file stream to read from. Or this folder might be in an AWS S3 bucket, for example, in which case Dataiku is going to handle all the details of the connection and opening the web stream or WebSocket or what have you, and give me a stream that I can read from for that. So what I'm doing here is just allocating a temporary file and downloading the video to that file. I open it up in OpenCV, I grab my frame, encode it as a PNG, and then return that data back to the calling function. So that is how I can extract a frame from the video. This is actually the only part of the code that uses that OpenCV. So now what I can do, this is how I actually split my videos into images. The file name of the video has encoded data about what's actually going on. So I've got a couple maps here to decode those, and I put them into different functions. And then I grab my emotion video folder, which again is this Dataiku folder function, or folder object. And if I look in my inputs, it gives me the input ID for that and all the information I need. I also have an output folder that I've established. And again, I have the ID over here. So I grab a list of all the file names in that folder. So I'm grabbing all of my videos. I'm adding some columns to my data frame as I decode the different parts of the file name. And then I'm looping through all the frames that I want. And in this case, I've decided to get a frame every 5% of the video. So I end up with 21 from 0 to 100 inclusive. And for each row in my video data frame, I create a new data frame, which has one row per image. and contains the image path and also the emotion of that image in plain text. And that becomes my primary data frame. I then loop through this data frame. I make sure that the image, that the image file doesn't already exist, because this loop can take quite some time to execute because we're loading the video over and over again and pulling out the frame. I extract the frame, I upload that to my images, I write my metadata out to a data frame, and I'm good. So the output we have coming out of that is this metadata data frame, which is going to have the video path, all of the features, the frame identifier, and then the image path. Each of those image paths corresponds to a file in the emotion images folder. And this will take a second to open because there are 30,000 files, about 14 gigs of data. And each of these is going to be a frame that was extracted from a video. So the next thing we have to do is to take these images and split them into our training and testing data set. And there's one little interesting thing we have to do. When we train the deep learning network, we feed that recipe a data frame or a data set containing the path of the images we want to use for training. When we test the neural network, we have to give it a folder full of image files, and it uses all of those images to test. So I have a quick Python code script here. I'm getting ahead of myself. So first I have a split function here, which will take that metadata data set and split it. So I group all of the rows by video path. This is very important because if I don't, then I run the risk of having image frames from the same video appear in both training and testing, which is really going to mess up my isolation of training and test data. So I make sure that grouping by video path, all of the frames from one video go into training, or all of those frames go into testing. I have a 80-20 split into testing and training images. I then have a Python code here that all it does is it will load my testing images data set, and then for each image in that data set, it will copy that image into a separate folder so that I end up with a folder that only contains training images. And so now what I have is I have testing image files, I have a training image data set, and I am good to go with my video preparation. So let's look at the next part, which is the actual deep learning. So we'll talk about training the deep learning network. To do this, we start with a pre-trained ResNet model, and then we retrain that. So to jump back over here, I can close this flow zone and zoom in on this one. So these networks we're working with are already trained. What that means is the plugin that I downloaded before will let me, will let me download a pre-trained network. So if I go up to my project menu and go to macros, I can download a pre-trained model. I tell it what folder and what model. So all of these are different architectures of deep learning network, and they all have been trained on ImageNet, meaning out of the box, they are able to identify the images in the ImageNet database. So I've downloaded this and I placed it in the original ResNet folder. If you look in that folder, you have just some configuration information. Model info has the architecture that we have for the network. And then we have labels for all the images the network was trained on. So you can see things like goldfish and a Afghan hound and a coyote. There's really a very large amount of images. I forget exactly how many, 1,000 different images, some of which are espresso, meatloaf, animals, all sorts of things. The reason that this is useful is this network, it can identify these objects. And you'll notice, none of these objects are the emotions that we care about. However, due to the nature of a deep learning neural network, there are a number of different layers, and each layer is kind of like a filter that is trained to recognize a specific part of an image. So you might have a filter that recognizes a curved line, and that would help to identify, say, a screw. So starting with a pre-trained network means that out of the box, the lowest levels of our network are trained to interpret parts of images. They may not be the images that we start with or the images we want, but they are better than random weights by a large margin. So I can take that original ResNet, I can take my image folder, I can take my data set of training images, and if I go to recipe, I have this section for deep learning on images. You select that, I get this retraining image classification model. So let's look at that recipe. It's worth kind of digging in a little bit. So this is all, under the hood, this is all Keras. So you can look at the documentation for Keras, and Dataiku has pretty extensive documentation as well to get more information. But the data set we fed in, we tell it what column the path to the image is, and this is the path within the folder that we use as input. We tell it what column to use as the classification label. We give it a train test proportion, a random seed to do reproducible stuff. The model stuff, we don't really need to worry about much here. I think the default is average pooling, or I may have changed that. I honestly can't remember. The relevant thing here are the layers to retrain, and then whether we want like regularization or dropout. I won't go into the dropout or regularization, but layers to retrain is really going to be based on your amount of computational resources available and your specific goals. So I can select the last layer, all layers, or some number of the last layers. The reason I might want to do only the last layer of the network is that is by far less computationally intense than retraining an entire deep learning network. So if I wanted to do something quick and dirty, or I just wanted to see how my performance was without doing a whole lot of computation, I would select just last layer. In my case, we were doing this for a sort of proof of concept blog post sort of project. So I wanted to train all the layers. I ran this on a pretty beefy AWS GPU instance, so I wasn't that worried about it. I ran it for, I think, 48 hours or so. I forget how much money that ended up being in computation, but it was pretty reasonable, but it was more than $0. So let's take just 1 second to talk about that. The Dataiku instance, the server actually running this DSS application, is not necessarily the place that you want to do all this computation. So Dataiku out of the box will interact with a lot of different things, including Kubernetes clusters. And if we look at the plugins, a plugin that's available is EKS clusters. So we can interact with the Amazon Elastic Kubernetes service as a cluster. So if I were to go here to my administration settings and look at clusters, I could create an EKS cluster that is a interface onto AWS. And then when I go to my actual project and I'm wanting to execute this large deep learning model that I want to run for some amount of time, if I go to advanced, I can select the container that I'm interested in using. So I could say I want a specific container and I want this global container configuration, which might then deploy this training job to my EKS cluster. The advantage there is if I have a large user base here for Dataiku, I probably don't want the user interface computer getting bogged down with things like large training jobs. So I can easily manage the execution of those things by assigning them to different containers and so on and so forth. And notice I can also set the project default, which I think the administrator can enforce. So I can force my users to use containers for these execution and offload that computational requirement to the EKS cluster. As far as the optimization goes, I'm not going to go into too much detail about these parameters. I think I have some more information and links in the write-up. This is all Keras, so the Keras SGD class, you can give it custom parameters, determining what type of momentum is used here. And these are just values that I think I did some experimentation and used some intuition and decided to run with. The training is where you really determine how much computational power you need. In this case, I set it for 400 epochs, 100 training steps per epoch, and a batch of 32 images per step. So this is a lot of training. This is where I ran it for, I think it took 48 plus hours on a beefy AWS GPU machine. One very useful thing here is this data augmentation. So in Keras, there is a image data generator class. That might be the name, it might not, I can't recall. And what it does is it takes an image and then generates a transformed image. So here I'm telling Dataiku that for every input image, I want 3 more images generated. And with these parameters, I can tell Keras and Dataiku exactly how to manipulate those images. So I'm saying here that I want the width to vary within 10% of the original width. So it's going to stretch these images in the X and Y direction. It might zoom in or out up to 10%. It might flip it horizontally. I have this fill mode that says if there's any white space, so if it shrinks the images and needs to fill in the edges, it just fills those with the color white. So in a large part, that is all of my training information. And then I ran this for quite some time. And afterwards, we end up with the trained ResNet model. So if you open up this folder, you see another model info, which is going to have the same configuration with the exception of the last couple layers, and model labels showing the new labels used for these objects. It also will have the weights. Just one kind of aside here, since this took 48 hours to train, I really want to make sure that we don't accidentally delete this information. So if you go into the settings for this folder, you can go into, it'll tell you where it stores this. And this could be a file system. This could be AWS S3, whatever you like. Under advanced, you can set the rebuild behavior to write protected, which means never rebuild this data set, even if someone tells you to. And that way you can make sure that it is not ever going to be erased unless someone explicitly goes in and changes the settings and erases it. So at this point in our project, we have built our network, we have prepared our data, we have trained the network, and we are ready to test it. So now let's look at measuring the accuracy of the model. And from here on out, things get pretty straightforward. It's pretty easy to set this stuff up until we get to deployment. So for testing, we take these test image files in our trained network, and we create another recipe from deep learning on images for image classification. And this recipe is very straightforward. All it does is take the maximum number of labels you're interested in and the minimum probability threshold. So what this means is I could say I want the top 3 labels, or I could say I want any label that has a probability of at least 0.1, so on and so forth. I want to see everything, so I set this to all 8 classes and a minimum probability of 0. And again, I could execute this off server if I like. What that gives us is this data set containing each image file name and a JSON object with all of our predicted labels contained within. So I need to do some manipulation of this in order to get to a happy place. So I can use my visual data preparation recipe and kind of do some manipulation. So the first thing I do is use a unnest step. So built into Dataiku is the ability to read this JSON object within a column and then to unroll it so that you have a column for each JSON attribute that was there, which is very handy. Then I can modify a row with Python code. So this allows me to run a Python function over each row, and that Python function can return a new row, and that row will replace the original. So let's look at what this actually does. So this function will get called once per row in my data set. And what it does, we have a list of all the different emotions. For each emotion, it just loops through and reads that prediction number and records the maximum value and the label of the maximum value and creates these new columns here. Then we extract the label from the file name. So if you look back at the file name, we have the emotion within that file name. And we have a correct variable that is 1 if the max label equals the correct label, or else it's 0. And then we also decode the image and restore the video path so that I can go back and group these things into the same video. So that ends up here with max prediction, max label, video path, and label. And now I have a data frame with 1 row per image. So what I can do with that, I'm already in a pretty good place, and I could potentially stop here if I was only interested in the image level classifications. Because if I go over in my data set exploration and look at the correct label, if you hit this drop down, you can hit analyze and get an off the cuff sort of analysis of that column. So we can see here that 90.7% of the values are 1, meaning I have an accuracy of 90.7 on my classification of my test video images, which is very good for this problem. This is not an easy problem to solve. So what I want to do now is recombine these things so that I can get my labels for videos. So I have a recipe. I can go to this group recipe and group everything by video path so that all the frames from the same video get aggregated. And just to do there's a few ways I could do this. I could take the average value of all these fields and then take the highest average and make that the selected label for a video. Or I could do what I did here, which is take max label and concatenate them, which is going to give me a list of all the different labels for the images for each video. I also saved the first label, and remember, this is the ground truth, so it's all the same for the same video. So I just grab the first one and save that. And that gives me this, where I have a video path, I have all of the votes for that path, and then I have the ground truth. I then take that and I do one more preparation stage where I modify the row with Python code again. And in this case, I use the most common version of counter, or I use a counter and grab most common and grab the most frequent label and make that into a column, and then put most frequent correct, and make that into a column if the two labels are equivalent. So now I have my data set at the very end of scored videos, where these are all of the test videos now that have been scored. So if I look at my correct variable and hit analyze, I have a 97.2% accuracy rate on extracting the video or extracting the emotion from these videos. So combining the images together and doing max vote took me from 90% to 97% accurate. So pretty good. We were very, very happy with this result because again, emotion detection is not an easy problem. Granted, the data set we're using is a very clean academic data set. So in the real world, you wouldn't expect to see something that high, but it is a very promising result. So now that we've tested the model, we want to visualize the results. So we'll throw together just a quick chart and image to show these accuracy statistics. We will build a more in-depth dashboard later on as part of the production pipeline. But just off the cuff, Dataiku lets me build charts and statistics for my data sets. So if I go to charts, I don't know if there's a quick way. Yeah, I'll throw away this chart. So I'll build it interactively. So I hit charts within my data set and I can just build a sort of a drag and drop sort of interface. So I can go to tables and select a colored table. And I want to build a confusion matrix. So the rows of my confusion matrix are going to be my ground truth, which is my label. So I set that to rows. The columns are going to be my predicted value, which is most frequent label. And then for the actual data, I want to know the number of records. And so that gives me this right here. The colors are kind of horrendous off the bat. So I'm going to take this and scale the opacity down so it's nowhere near as prevalent. And I have a quick confusion matrix, which I can call confusion matrix. And if I like, I can actually publish this to a new dashboard here and make it more permanent, but I'm not going to do that just yet. Along the same lines, there's also a statistics tab where I can do numerical statistics on one or more columns. And in this case, I can do a new card. I just selected univariate analysis on my most frequent correct variable. It just shows you a little more information in terms of numbers and means and medians. So those are very simple, simple visualizations. We'll get more in depth here in just a little bit. So that brings us to the production pipeline. So now that I've tested this thing, I have it scored, and I know I'm 97% accurate on my test data. It makes sense to try and make something that someone could actually use in the field. That is not what I meant to do. So to do that, it's almost exactly the same as my testing pipeline, combined with the very beginning data prep. So we will prepare the images, score the images, pull labels out, combine them to get video labels, and evaluate labels for motion videos. So I'm checking my readout here to make sure I'm doing everything right. All right, great. So that's where this comes from. So for my production pipeline, I've created a new folder, which I'm calling videos to score. And it's going to be empty right now because I don't have any videos to score. And what I do here is I have almost exactly the same Python script as before that uses this extract frame and pulls out the frames from each video. And remember, I have to execute that in my OpenCV Python environment. And so now I've extracted the frames. I go through the same data prep stages to score those frames, combine those scores, pull out. In this case, I'm actually doing the average score instead of doing the majority vote. It ends up being about the same result. We tested it both ways. It didn't really matter. And it just ends up being a little easier because the average results ends up being the probabilities that you return for the API. And I have a folder or a data set here to contain my scored results. And here's just some stale results that I ran earlier. I don't think you'll have these in your project. So that is the production pipeline, and pretty straightforward. In order to really get some use out of that, we'll do a couple things here. Let's switch over to the next step, which is visualizing and automating production scoring. So we want to build a dashboard and an execution scenario. Well, and the two steps are build the dashboard and build a scenario. So just to make things easier, if you wanted to do this, you could take a couple videos from your motion file, a motion folder, download them, and put them in this videos to score. It'll make it a little easier to have some data in this production scored videos folder. But what I want to do is build a few insights and combine these into a dashboard. So if I go to insights, I've already put these together, but they're relatively easy. So the first one I'm concerned with is just the overall score of a video. So I called this emotional composition of video, and I'll go to edit here. This is the same chart format that you saw earlier. So it's just all drag and drop. In this case, for the X values, I want to have all of my prediction values. So every prediction I might make. The Y value is the video path. So this gives me a bar for each video. And within that bar, it shows me the average value of the different predictions over the images. So this effectively is showing me what the videos were classified as. So here on index 2 video, you can see it was 92% calm and 7% or neutral, and then a couple slivers of angry. So this is a video level view, which is interesting. But there's one other thing we can do, which is interesting as well, which is we have all of these images that we score, and the images are going to each have individual breakdowns of emotion. So that's where we get this emotion per extracted frame insight. And what this effectively shows you is the emotions contained within a video over time, because down here is the percentage of the frame, and then within each of these is a line chart showing what the classification for that frame was. And if I go to edit, this is just a different type of chart. It's what do we call a stacked line chart, I suppose? Yeah, stacked area, 100%. The Y values are all the same. This time the X value is my frame ID. And I have a subchart for video path. So now I can see that my index 0 video appears to, let me go back to view. It appears to have started angry and then gone to some surprise. There was a little bit of sadness that came out, and so it's kind of all over the place. And I specifically picked some videos that had different bits of emotion in them. So we'll look at that here in a little bit. So now I can take those insights, I can build a dashboard and put those two things on it. And here's a pretty quick and dirty visualization of the results of scoring that one folder. So this is how I can view my results. Now let's look at a scenario to actually automate the scoring. So what I can do to score videos is I could take one of these emotion videos, I could download it, I could then go back to my flow, I could put it in my videos to score file, and then I could go back to my flow and I could upload my video into, or I could tell Dataiku that I want to build my videos to score dataset. But what I would rather do is have something that does this automatically. And for that, I can use my, I can use these scenarios, which of course, there we go. Let me get back to full screen. So if I go to the run section here, I can go to scenarios. And so I built one called Score Incoming Videos. And so here, the steps you need can be viewed. So the first thing I want to do, let's consider how this is going to be run. So what's going to happen is I'm going to put videos in video to score, and then I'm going to run this scenario. So the first thing I want to do is delete all of the data sets that contain the information from anything that was run before now. Then I run the build images to score. Then I score the images. Then I do the prep steps. I build the video data. I hit refresh dashboard. And then I clear the video and image files because I no longer need those files and I want to get set up for the next time that, that this gets called. So this scenario, run end to end, will score anything inside that videos to score folder. And then it will refresh the statistics and get rid of the files and clean up for next time. So now I have a way of automatically scoring everything in videos to score and making sure that data ends up in production scored videos. And I will, I'm not going to run an execution right now because we'll actually show you that here in just a second in the next step. So now we want to deploy this as an API. So there's a couple things involved here. It gets a little hairy because we're doing some advanced stuff. There's other methods of deploying these APIs that may be easier that Dataiku has kind of worked on in the meantime. But this is a good demonstration of some of the advanced features of Dataiku and how you can deploy a relatively complex API. So what I'm going to do is I'm going to have an API. I'll have an endpoint, and I want my user to be able to submit a video file, which will be base64 encoded. They will submit that to the endpoint. The endpoint will place that video inside the videos to score folder. It will then trigger the scoring scenario, wait for that scenario to finish, and then return the results. So we need to create some API keys, endpoints, deploy, and then we want to test it using a Jupyter Notebook. So, and just one security note, API keys are as sensitive as usernames and passwords. You notice I flashed one up on the screen just now. I'm on a server that's behind a VPN, so I can be a little careless with this, and I'm going to change all the keys after we get done with this demo. So I'm not being as reckless as it may originally seem. But I need two different keys. I need a key to access that API because I want it to be a secure API. And then I need a key to allow the API to upload a video. So if you go into your user settings, one of the sections here is API keys. And you can create as many as you like, but you create one of these keys. And anyone with this secret key can perform any action that you're allowed to perform. So again, very sensitive things. And I record that key, and I will use it in just a moment. So for APIs, Dataiku handles all of the API deployment and monitoring and all that, and does a very good job of that. So I can go into my API designer and create services. And so each of these services can have a number of different endpoints. And the endpoints are pretty self-explanatory. If I were to create an endpoint, I can have a prediction model, do custom predictions in Python or R. I can run arbitrary functions in Python or R. I can run a SQL query, or I can look something up in a data set. There's a whole lot of stuff we can do here. I can use enrichments to add columns to data that comes in, a bunch of stuff. In this case, I'm doing a custom prediction with Python. So I will kind of walk through this. There's a lot to unpack here, so I'll go as slowly as needed, hopefully. So there's a couple of constants here that you'll need to change if you want to run this on your instance. First, I have the URL for the Dataiku DSS instance. This is not the same as the URL for the API endpoint, but this is how you access the actual server that you're working with, which you can get up here in your bar. I have the key that I generated for my user, and then I have the ID for my videos to score folder. So if you go back and look in your flow for all of these folders, if you open them up and go to, let's see, I don't know if advanced will show it. I was going to see if there was a supported way of seeing this. I don't see one immediately, but if you look in your menu bar, you have the ID of that folder right there. So we copy that ID here. The project key you also need, which shows up in your menu bar. And then you need the ID of the scenario that you created for scoring, which again, like most of these things, shows up in the menu bar when you're looking at scoring. So given all of that information, we can create our classifier. So what Dataiku does for a custom prediction Python endpoint is it gives you this class structure. And then when someone calls your API, it executes this predict method, and it gives you a data frame containing all of the features that were passed in. One note here about the code, I had a bit of a problem running this code because my server is not configured very well. It is a SSL enabled server, but it does not respect its own root CA certificate. So it actually is unable to validate its own SSL certificate, which is bonkers, but that's what I had to deal with. So there's some code at the bottom to let me disable SSL verification. And that's what this context here is. You don't need that, probably. It doesn't hurt to run it with it, but it may not be required. So I can set my Dataiku code to establish a connection to a remote DSS server. Now, to take a step back, the architecture of Dataiku is you have your DSS server, and you have your automation server, and then you have API nodes. And forgive me if I'm missing a class of thing here, but the API nodes are not necessarily on the same machine as DSS. So that's what we're doing here. We're setting our remote connection to DSS using the URL and key that we created. As a side note, I could have done this differently if I wrote code that manually loaded my network and distributed my weights and all that. I could have avoided having to upload back to DSS, but I chose to do it this way. So I take my features data frame, and then I pull out the data folder, which is that videos to score folder, using my Dataiku API client. And then for each row in the data frame that was passed, I pull out the file name and I upload that data. So I call base64 encode, and so the data is encoded. So I take the base64 data, I decode it into the raw data, and I push it into this upload data. I then grab an API client. I don't actually know if I use that. Oh yeah, I do. I use the client to get the project. I use the project to get the scenario. So now I've got an object for the scoring scenario. I call run and wait. So it's going to execute that full scoring pipeline, and then it's going to make sure that the outcome of that run was success, though I don't actually check that value. I probably should. Once it's run, I get the data set from the scored videos, and I make a data frame out of that, where I have the name of all of these predictions. I have the video path. I take my emotions. I rearrange this data frame to add the emotion value to the data frame. So I'm adding a column for each emotion prediction average. I then add a column to indicate the overall prediction. And I rename my columns so that they're in the proper format, because Dataiku expects this proba underscore label format to show the raw probabilities. And I return my decisions and probabilities. So that's a lot to digest. But if you set things up in this way, it becomes very easy from here on out to actually deploy this. Now, on your particular instances, you may not be able to deploy, but I'll show you what that looks like just so you're aware. So if you hit push to API deployer, you can give this thing a version and some other information. Oh, I missed a step though. So let's cancel that. So I want to go to security and create an API key here. Just because I want this to be an authenticated API endpoint and not just one that someone can hammer. You could do a public one if you wanted, but I mean, good practice is not to. So I push that to deployer. And John just let me know they can actually, you can deploy things if you like. You have to give it a version ID and hit OK. It'll build some packages. You can then open the API deployer, and it'll show you all of your endpoints. And notice I've got some other things on this server. But the relevant thing is here's this V7 endpoint. I can hit deploy. I can tell it to update the package or create a new one, depending on how the changes are, and it will push it out to my API node. I'm not going to do this because I might have broken something just now, and I know live demos are not very friendly. So I'm going to go with the stuff that I ran before and that I hope works. So now we have deployed the endpoint. It is up and running. So if I look at that page I was just on with the API deployer, I can see that Score Video v6 is in fact running. It's running on my local infrastructure. So you can define different infrastructures like clusters. And again, this could be, I believe this could be an EKS cluster. I know it can be a Kubernetes cluster. So here's all my things. And I do have in the project itself, I painstakingly created a test query. So in your API designer, you are able to give test queries for your predictors. This one was a little bit annoying to create because my test query necessarily contains an entire base 64 encoded video to test. But if you run that test query, it should chug through the scenario and give you the results. So now we want to test our API. So to do that, the easiest way is to create a notebook. And notice, I could do this now on a separate machine outside of Dataiku, but it's nice to keep everything together. So I create this test scoring API notebook. So what this will do is actually upload a video and kick things off. So I have a couple constants here. Note that I have the URL of the API node, which you can get from that API deployer will give you that node. If you look at your service, it's right here. One thing that actually I broke and threw me for a couple hours, in this case, I have the API node and DSS running on the same server. Make sure your path is right. If you put the wrong port number here, it will give you an annoying bug that takes forever to track down. I have my API key, I have my deployment name, my endpoint name, and then the Emotion Video folder key. So what I'm going to do here, the reason I need this, this key, is I'm actually going to grab some videos from my Emotion Video folder and use those to test. So I don't have to have any videos on my local machine or anything. I have it set up two different ways. So I could either do a random sample or I could pass in some explicit video file names to score. And I also have my verify SSL because I had to do that workaround here too. So I have these file names because in particular, they are, I guess, interesting videos in that they will go through different emotions and not necessarily be scored, 100% sad or whatnot. So we can actually run this interactively. Here's some code to decode my emotions. And now I grab the videos from my Emotion Video folder. I grab the particular file names I'm interested in, and I show that data frame. So I have these 4 videos. Here's their labels. So now I want to download those videos from my Emotion folder. And that's what this does. It's very similar to that extract frame code in that I allocate this temporary file, I write the video to that file, and now what I do is I base 64 encode the file, and I create an array of records which have the file name and then the base 64 contents of the file. So that'll take just a moment to run. So, and here's some code to disable SSL verification because of my misconfiguration. And so here's the code to actually call the API. Dataiku gives you a very nice package called Dataiku API. So I can create an API node client with the URL and the deployment name and my API key. And then I can call predict records and give my endpoint name and my array of records. And that's going to give me this predictions object. So this should take about a minute, assuming it runs on the same speed. And when I run this, I'll notice a few things. So down here, it says now it started the scenario. So now it is running that scenario because remember my API endpoint uploads the videos to DSS and then triggers that scenario. So as things go, you should see different jobs be completed and so on and so forth. One question that was submitted, I guess was from Sam, who he actually left, but he asked if the frame selection was random and then narrowed down. It's nowhere near as exciting as that. I just grabbed arbitrary frames, 5% of the video all the way through. So we're still going through. Now we're building the prepared data set. Now we've finished the scenario. So the videos have been scored. So, and in this whole time, my API call is still waiting to return. And now after 50 seconds, 57.5 seconds, I've returned from my API call with this predictions object. And so this object has some context as far as, here's the endpoint, the version of the endpoint, the service, results. And for each record I gave it, I get this result object, which shows whether or not the row was ignored. It shows the overall prediction, and then it shows the probabilities for each of the predictions within that video. So I have a number of those. And down here, I have just some utility code just to examine these predictions. So here is the ground truth and the predicted value, and then correct if it's correct or incorrect. And then I have just some quick code to build pie charts showing the distribution of all of those video emotions. So at this point, we now have all of the APIs. I've deployed this to an API server. I have tested this API and plotted my results. Quite a set of accomplishments. Now we have a service that actually could be used by the business or the users to automatically submit, score, and retrieve videos. There's one more thing we can do to distribute this work, and that is to build an app. So in the latest version of Dataiku, they have created the ability to create applications. So if I go to my project menu, I can go to Application Designer. And an application is essentially a limited copy of your project. So look at it this way. If I wanted to let users access Dataiku and use this project to classify emotions, they're very quickly going to step all over each other. They're going to put videos in video to score. They're going to run the scenario. And while that's running, someone else is going to put videos in that same folder, and there will just be general chaos. With applications, I can let a user create their own isolated environment. So I can decide exactly how that app works. In this case, I'm not going to display flow or lab or code or version control. All of that will be hidden. And I can select exactly what data sets and folders and machine learning data are included in the application. In this case, I'm adding all of the stuff that is needed for production scoring. So this trained ResNet data gets copied. All the data from the scored videos gets copied. And down here, I'm describing how the application works. So I can add different steps that do various things like upload files, edit data sets, download, send emails, I think is one of these. Actually, email may not be, but there's a whole bunch of things here. So the steps that I'm allowing the user to do is to upload videos they want to score, which go into this folder. And the tile behavior can either be to open the folder up or just directly upload the file. I'm letting them run the scenario to score the videos. I'm letting them view the app dashboard. And then if they'd like, they can download it as a PDF. So I'm not quite sure what the advanced does. And also, so in advanced, actually, I can package this app up as a recipe, which I'm not 100% familiar with exactly how to use that. But effectively, I could make classification of videos into a recipe block that could be placed into a Dataiku flow. So you can encapsulate a whole bunch of complex behavior and then add it as a black box into other flows. So once I have this application created and saved, now what we can do is from the main Dataiku menu, there is an option to open up these applications. So here's the AWS Dev Day app I made. And I can create an app instance. And so when I create this instance, It is exporting only the data I need and building my own copy of this project. So now, if I were to try to do things, I have an isolated environment in which I can score these videos. And I think I have a relatively quick link to a video just to demonstrate this. So I can drag and drop a video into that upload window and it will upload for me. And then I can hit run now and it's going to run this scenario. And multiple users can be using their own copy of this app at the same time. It is not going to conflict with other things. So I'll let this run just for a second. And notice I've got all my notifications down here and all that good stuff. So my scenario has finished running and now it returns and says that it was successful. I can view details, all that good stuff. And I can open up my app dashboard, which is going to show me for this one video that I uploaded, here's how it scored. And if I go back, I can download this app dashboard as a PDF, which you can then email or do fun PDF stuff with. The last thing that we will look at in these applications is a different way of distributing this. Oh, and I'm all over the place. All right, here we go. So if I look at my application designer, this will let people create emotion applications on this DSS server. Maybe I have an enterprise deployment or otherwise I want to run this somewhere else. In my actions, I can create a plugin application. So if I create a plugin, and I'll just give it a stupid name, convert. What this does is it gives me something that can be installed into a DSS instance. And once installed into an instance, it will allow users to create a Dataiku or a emotion classification application without actually ever having the original project. So if I go to download this plugin, I now have a zip file containing only the information needed to actually classify videos. If I was to distribute this or sell it or what have you, I do not have to worry about leaking my training data or leaking my business logic or anything else I did. It only contains the components necessary to run that app. So let's look back at what we have done so far. We have distributed this as an app. We have built it. We've created an API that is callable from the real world. We've tested the API and built visualizations. And it looks like we did all of that about 30 minutes ahead of schedule. So I'm going to call that a good thing. We can go ahead and transition into the office hours sort of discussion Q&A portion of this, for which I will have to defer to Sydney or John as far as how to actually make that happen.
Yes, thank you so much, Coop. So yeah, we will start our office hours early. Please, now you can take the time to log into those credentials you received this morning. Again, if you didn't receive any, please let me know in the chat and I will get you set up so you can participate. If you have any questions about the presentation, please also put those in the chat and we'll be happy to answer them. But we will be here as you walk through the project to answer any questions you have.
Sydney, is there any way to enable these folks to actually speak if they had questions that are easily verbalized?
Absolutely. So I will give everyone permission to talk, or you can raise your hand as an option in the chat. So if you do that, we'll make sure that you're unmuted and you can talk freely.
And I'm sure as a warning, if you have permission to talk, we can take it away at any moment. So everyone play nicely.
We hopefully won't have to, but
I'm sure we won't.
again, just as a quick note, the instance that we shared will be available to use through end of day Friday. So you do have the rest of the week to play around with it. And if you have any questions, I'm sure John or Coop can share their contact information, or you can reach out to us. You all have my email. So if you have any questions, please feel free to email me and I'll make sure that I get you the assistance you need.
Yeah, so a great question came in via the Q&A just about the convolutional neural networks in general, asking which deep CNN we used. So ResNet is the architecture that we selected. Dataiku has prepackaged versions of VGG16 and Inception v3, as well as there's at least one more in addition to ResNet that I'm blanking on. And it does allow you to interactively specify your own architecture for a deep network if you like. So I made the relatively arbitrary decision to use ResNet. There's not a lot of complicated logic that went into that.
Hey, Coop, it looks like you have another question in the Q&A.
Yeah, I was gonna type that one out because I think that may be easier for folks to reference later.
Sorry about that.
Oh, you're fine. And don't worry about asking too many questions at all. This is all good stuff.